Okay, so in this question, the first length we're asked to find is OX, and then the second length we're asked to find is BX. Okay, so if we look at the first, we're being asked to find BX, OX. So we've got this triangle, and we know two angles, so we can obviously work at this third by just taking the sum away from 180. So that's the first thing we're going to do. So 180. Take away 20 and 68 gives us 92. Once we know this angle, we can then use the sine rule, and the sine rule says the sine of an angle opposite a length gives a constant. Okay, so we have a look at our formula sheet here. We can see the sine of an angle on the ratio of the sine of the angle and the length opposite it is always equal. Okay, so that's the first thing we're going to do here. We're going to use the sine rule. So, using the sine rule, we're going to get that OX over sine 20 is equal to 1100 over sine 92. Now rearranging this for OX gives us 1100 sine 20 divided by sine 92. Okay, so if we go to a calculator and work that out, it's 3 significant figures, 376 meters. Now, we have a look then in the second question. We've been asked to work out BX, which is in this second triangle. Now we've got to remember, we now know OX. Also, we know this angle BOX. So the angle at BOX would be 180, take away 68, 112. So now we have this angle, and we know both those lengths, so we can use the cosine rule to find BX, because if we have a look at our formula sheet, this length squared is equal to, this length squared is equal to this length squared plus this length squared minus twice this length times the cost of the angle between them. So we do have that information. Okay, for this, so in this case we're going to have BX squared is equal to, from the question, 450 squared, from our previous answer, 376 squared, and use those again. And its cost of the angle between them, well, we've just worked out, it's 112. Okay, so we took the square root of that would give us what BX is. Now you've got to be careful keying this into your calculator. This is quite often where people will go wrong. But if you take your time and you've got a direct algebraic calculator, just key it in exactly as it looks here, should give you the right answer. Okay, so going to our calculator, we get 3 significant figures, 6, 8, 6,